All right, so in this lesson, we're going to go in a little deeper with similarity proofs. Okay, so we're going to talk something about the products of the means is equal to the product of the extremes. All right, so before we get into the proofs, let's kind of talk about what that means. So in exercise 1, we want to test the truth of each of the following fractional equations by seeing if the products of the means is equal to the products of the extremes. So essentially, the product of the means and product of the extremes, basically, when we cross multiply, does it work, right? So does 3 times 3 equal 6 times 1? Well, 3 times 3 is equal to 6 times 1. So this is 9, and this is 6, so that doesn't work. So 15 times 4 is equal to 12 times 5. I believe this is 60 is equal to 60. That one does. So in this case, the product of the means is equal to the product of the extremes. So when we cross multiply these two times is equal to these two when we multiply them. So same thing with this. So does 77 times 15 equal 3 times 35? So 7 times 15, so that is 105, and then 3 times 35 is equal to 105. So yes, okay. All right, so the top one on the left and the bottom one on the right are what we call the extremes, and the bottom one on the left and the top one on the right are what we call the means. Okay, so let's see how this ties into proofs. So let's take a look at exercise 2. So in the diagram below, AD and BE intersect at C, as well AB is parallel to ED. So we're going to mark all the angles that are of equal measure in this diagram based on our givens. So based on the fact that AB is parallel to ED, we know that this angle is congruent to that angle. So A is congruent to angle D, right? There are alternate interior angles. And we know this one is congruent to that one. And then we also know that this one is congruent to this one because they are vertical angles. So angle ACB is congruent to angle DCE. Okay. All right, so for letter B, which two triangles are similar? How do we know? Write down a similarity statement below. Okay, so we know based on this, we know that triangle ABC is similar to triangles DEC by angle similarity. Okay. Now we only need to know 2 angles, but I mean in this case we marked all of the angles, but still by angle similarity these 2 triangles are similar. Okay, so for C, write down a reason for each of the following statements. Now, when we do similarity proofs, sometimes you guys are going to see proofs that involve this situation. Okay? Now, they don't mean anything crazy. Now, whenever you see like this ratio, okay, so something like BC over EC is equal to AB over DE, this reason is corresponding sides of similar triangles are proportional. Okay, you can also write CSSTP. Okay, now this reason, this is the result of this after we cross multiply. So kind of like what we did up here. Okay, so for the reason for this is the product of the means is equal to the product of the extremes. All right, so let's take a look at some examples of this. All right, so let's look at 3. So in the diagram below, points N and M, N and P are located on sides MQ and MR such that NP is parallel to QR. We want to prove MN times MR is equal to MQ times MP. Now, this right here, if you are being asked to prove this, this tells you, this is like a red flag that you need to do a similarity proof. Okay? Now, we need to take a hot second before we actually go through and start our proof. Because, I mean, it's obvious, I think, to understand what in this specific case, what two triangles you're trying to prove similar, but that's not always going to be the case. So we kind of have to take I'm going to take a second before we start our proof to kind of figure all that out. Now, I have a little trick for us. This comes after we say this. So before we say this, we need to say this. So let's get this into some type of proportion. Now, again, I have a little trick. So I'm going to label this 1, 2, 3, 4. So when we do this, we want to put 4 over 2 is equal to 1 over 3. So to set up this in a proportion fraction, something like, I'm going to do MP over MR is equal to MN over MQ. Okay. Now there are multiple ways that we can set up a proportion probably to end up with this, but this is one little trick that I like to use to kind of help me get this in this form. Okay. So now we need to tell what two triangles we're trying to prove similar. Now, how we figure that out is kind of based on what we're given. So we are given MP over MR and MN over MQ. All right. So we are trying to prove, in this case, MNP is similar to triangle MQR. It's not always going to be this obvious, so that's kind of why I wanted to go through it. So now that we know what now we know what two triangles we're trying to prove similar, let's prove them. Okay. So we start off with our given. NP is parallel to QR. Now, remember, we always kind of want to look for, can we prove this by angle-angle similarity? So I'm going to say that angle M is congruent to angle M by reflexive. And now, because these two lines are parallel, I'm going to say that this angle is congruent to that angle. Now, you're more than welcome to use these two angles as rather than these two, but I'm just going to use these two. So I'm going to say angle MNP is congruent to angle MQR. So if two lines are parallel, then corresponding angles are congruent. Okay. So now I can say that these two triangles are similar because I have my two angles that are congruent to each other. So triangle MNP is similar to triangle MQR by angle similarity. Okay? Now we're trying to prove this, but before we can say this, we need to say this. So my fifth step is MP over MR is equal to MN over MQ. And this is by corresponding sides of similar triangles are proportional. And now I can say this. Now that I've said this, I can say this. So now MN times MR is equal to MQ times MP. Now this is the product of the means is equal to the product of the extremes. All right. All right, so let's look at exercise 4. So given triangle ABC with right angle ABC, the altitude has been drawn to hypotenuse AC and terminates at point D. So this is a right angle. This is the altitude of triangle ABC. Now we want to explain why triangle ADB must be similar to triangle ABC. So ADB is similar to this whole big triangle. Okay? So this triangle is similar to that whole big triangle. Now, we are given that this altitude is drawn. So angle ADB must be a right angle. Now, we were also given right angle ABC. So angle ABC is a right angle. So then we know that angle ABC is congruent to angle ADB. Now, angle A is in both triangles. So we know that angle A is congruent to angle A by reflexive property. So by angle similarity, triangle ADB is similar to triangle ABC. All right, so for letter B, we want to draw ADB below so that ABC is in the same orientation. Okay, when you're given questions like this and diagrams like this, it is a lot more helpful for us to see kind of which sides match up to which ones. So I'm going to redraw both of them like they just asked. Okay. Now be careful of where you put your letters. All right. Now for part C, we want to give a short proof for why AB squared is equal to AC times AD. Okay. AB squared, remember, is just AB times AB is equal to AC times AD. Now this, remember, it comes from something like ratios. Okay. Now since triangle ADB is similar to triangle ABC, we know that corresponding sides are proportional. So we know that AD over AB is equal to AB over AC, right? So then that is why this is true. The product of the means is equal to the product of the extremes. Okay? This is by corresponding sides of similar triangles are proportional. Okay? These two triangles are similar by angle-angle similarity. Okay? And that is the lesson.